All right. Number 12. The growing raindrop. Suppose that a droplet of mist is a perfect sphere, and that through condensation, the droplet picks up moisture at a rate proportional to its surface area. Show that. I hate when questions go on another page. Under these circumstances, the droplet's radius increases at a constant rate. So
as the drop gets bigger, it just like absorbs more and more, basically.
yes, there's your drop. Your excessively large drop.
It's a chunky drop. What about that circle?
So, let's see. The radius increases at a constant rate. This is why I hate when it's on two separate pages, because I have to keep flipping back and forth to see what the problem says. Suppose that a droplet of mist is a perfect sphere, and that through condensation the droplet picks up moisture at a rate proportional to its surface area. Show that under these circumstances, the droplet's radius increases at a constant rate. So, I'm going to go ahead and write out the formula for volume of a sphere. 4/3 pi r cubed. So, let's see, things that I might need are dr dt, v, and dv dt. So, they literally don't give us any numbers, so we're just gonna roll at this point.
If the raindrop tried to roll, it would probably just go splat.
It would just keep picking up more drops. All right, what's the derivative of this?
dv dt is equal to 4 pi r squared dr dt.
All right, so going back to look at it. Radius increases at a constant rate. So I'm going to say for the moment, let K be the constant rate. Now, do either of you know the surface area of a sphere?
The derivative thing, except without the dr dt.
Yep. 4 pi r squared is the surface area for a sphere. So just something to hold on to.
So that's S sub sphere.
Yes.
Okay.
First I thought you said sub-sear, and I was like, are you searing the water droplet? I was a little confused. All right, so the droplet's radius increases at a constant rate. So that would mean that dr dt would be this K value then. So in this equation, I can replace dr dt with K and have dv dt equals 4 pi r squared times K. So this is dv dt is equal to this. Right? So this is just honestly, it's a weird problem. So I can take this and replace this here. Josh doesn't like this problem, I can see it. So 4 pi r squared dr dt equals k times 4 pi r squared. And I just put the k in front since it's a constant and not a variable. Can divide by 4 pi r squared, so dr dt equals k.
We already figured that out.
Yes, but we're trying to show that that is true.
Oh. Okay.
It's a weird problem, like I said. Because technically then we could say dv dt equals k times s sub sphere.
So is that all we have to do?
Yeah, we just had to prove that it changed at a constant rate, basically. So I said, not the best problem in the world, but I'm not inclined to give you one like that.
Thank you.
That's just a weird problem altogether. All right, flying a kite.
So what was the purpose of them telling us about the raindrop?
So that
Just
you
so
would
that
know
we
that
have
the
shape.
shape.
Yeah. We had something round that. would
Although
work
when
for
I
the
think of a
ground.
raindrop,
That's what I'm gonna say.
Yeah, I mean,
I
when
don't
you said
think
it was a
it's-
raindrop that was a sphere, I said, what in the gravity? Because, like, wouldn't
Oh,
gravity make
yeah.
it, like, kind of saggy?
Yeah. I went to draw my raindrop. Mine looked more like a Skittle. I wanted to draw like a little S on it or something. but-
oh,
It's one of the blue Skittles, those are not normal.
Or like an M&M.
I was like, blue Skittles don't exist.
No, they do.
They
They're
do.
tropical pack.
Okay, well, yes, I was
Not-
thinking
not
we
the
meant
original.
classic Skittles. I was like, no, they
Not
don't.
the classic.
That's not.
But this is
normal
more.
model.
This is like an M&M blue color.
Yeah. You want to eat it?
Kinda.
All right. Flying a kite. Ing flies a kite at a height of 300 feet.
Wait, we did what?
Ing. Or inge.
Inge.
Can you spell it?
That's like a.
I-N-G-E.
That's like a nickname for my name. Virgin.
No, it's not. No, it's not.
What about Gingy? Yeah, we call it Gingy.
Yeah, that's what
Inge.
Sarah goes.
Inge.
Ingy.
Inge.
Ingy. Okay. The kite is flying at a height of 300 feet. The wind carrying the kite horizontally away at a rate of 25 feet per second. How fast must she let out the string when the kite is 500 feet away from her?
I'm sorry, Miss Ing or Inge, but your parents came up with a really weird name.
All the Inges watching this are gonna be really offended. Inge.
Makes me think of hinge, like what's on a door,
Yeah.
except there's no H. So then it just
Excuse
looks
me?
weird. Why did it go round?
I don't know. I was having a moment.
I think it wanted to do a heart because it's like February, but like it only did half of it. Maybe it was hoping
I
for
don't like the
H,
shape
but-
it makes. It
No,
makes
I
it too,
know.
like,
It's too
short on the
rounded.
top. Yeah.
I know. I've tried to like. All right. So we were told that it is the height of 300 feet. The wind is carrying it horizontally away at a rate of 25 feet per second. So we'll have that in a minute. And then how fast will she let out the string when the kite is 500 feet away? So that's obviously it's flying over this way. So we're trying to solve for, I don't know, I was there a reason I was about to call that H? Oh, horizontally. I don't know. Sure.
Why not?
So, how are we solving for H again? Pythagorean theorem? Or,
Yes.
okay, good. You got this one, Virginia.
What? Do I have what now?
I said you got this, Virginia. I already figured out what H is.
Well, good for you.
Yeah.
D D D T. I like that one.
Did y'all ever have the foot book?
I don't think
Or not the foot book. The ABC Cat in the Hat book or Dr. Seuss book?
Maybe.
Big A, little A. What begins with A? Aunt Annie's alligator. A.
I don't think so. I mean, like AAA. It's like I feel like I think of like alcohol and
What?
Makes me think of one of those alphabet agencies, you know? Took up like 2 pages of my research
Put these up
paper.
here. Did we figure out what H is yet?
Oh.
Yeah, Virginia.
Let me think. $400.
Yeah. There we go.
Wait, 400 cows?
400.
400 feet?
Yes.
Now we know DHDT because we were told that it's flying away at a rate of 25 feet per second. So now, yes.
The 25 you said was already given to us.
Yeah, it was in the problem. So we're going to say D equals the square root of 300 squared plus H squared. So then we take the derivative, so d dt equals what? If you need to think about this as 300 squared plus h squared to the 1/2, you can.
I'm gonna say. Hold on. That's what I'm gonna say.
1/2 times.
Are we doing negative exponents or 1 over?
Oh. 1/2 times 2. Wait, did I just get rid of the 300?
No.
Okay.
Chain rule.
Keep it.
Oh,
Everything
I
inside.
You got
So,
this, Joe. Too much.
so then we have a plus h squared. And I guess we'll do it to the negative 1 now.
Times 2h dh dt.
Yep. So now 2 and 2 cancels. So I've got d dt. Gets Josh every time. Equals h over 300 squared plus h squared all under square root times dh dt. Now we can plug in d dt equals 400 over the square root of 300 squared plus 400 squared times 25. Should need a calculator for this.
Fair point.
Because on top I've got 400. What amount's in here?
That's 2,500.
Square root of that would be 500. We already knew that number actually. It's Pythagorean
25,000.
theorem to
I thought
begin.
that was- Oh goodness, I'm missing a couple zeros, aren't I?
I think so.
Goodness.
I'm not even 100% sure I have them all. My calculator's not right here. But I already know what this number is supposed to be.
90,000 plus, I guess, 160,000.
I think I'm missing a zero also. I think it's 250,000.
Yeah.
Which would be 400 over 500 times 25. 5 and 25 reduced to 5 times 4 is 20 feet per second. Is d dt. Virginia, you look confused.
I was just seeing how you reduce the 400 with, okay, so you
Just
got
cancel the
rid-
zeros.
5 zeros.
Okay,
Or I reduced by 100.
I prefer by zeros. It sounds better. Now that one's actually really fun.
and all the other ones you laughed at were actually funny.
Oh, the words.
To you.
It's just this one's even funnier because it's 3D.
— 16 is a sand problem. Sand falls from a conveyor belt.
Sounds so disgusted by you.
It was refreshing.
I thought for sure it was disgusting.
I don't know why, but after lunch I'm always so thirsty. But never for water. Just for like other
Yeah,
stuff.
that's a problem.
Yeah.
Really, math, we have so many problems.
At a rate of 10 meters cubed per minute onto the top of a conical pile.
I feel like it should be conical.
I feel like that would be pretty comical. Now, I was wondering why you were going around in like rounded sort of shape instead of drawing triangle.
I
And
finally
then it's
figured
like,
out how you've been drawing the cones so quick. Cause I've been doing one. I hate how when I go like that, it makes it rounded, and then I have to go like that and then that. That's so much easier. I didn't think about that.
Does Matt really like these ones?
Because she can see the 3D of them. Okay, this upside down cone is really throwing me for a loop.
What?
Yeah, mine looks like it's like floating. Something that's off. I might fill it in a little bit.
Good enough.
It's all about perspective, and it takes a while to get
Perspective.
the right perspective.
I need to watch that movie soon. I love
I was gonna say, you have seen it before, right?
I have seen it. I
Is
love
that
it.
sand?
It's not water.
Oh well, it might be wet sand.
Mine looks like.
Oh no.
Oh no, your sand, it's being non-uniform, you know, not conical.
So is mine. Mine's like kind of rounded out at the bottom a little bit.
Alright, there we go. Pile of sand
Yours looks like mustard.
coming off the conveyor belt.
Way too
Alright.
Oh, I thought it was too dark.
The height of the pile is always 3/8 of the base diameter. Don't catch that. How
The height
fast?
of it is always 3/8 of the base diameter.
Yes.
Is that what you said?
Yes. How fast are the height and radius changing when the pile is 4 meters high? Give your answer in centimeters per minute. Oh dear.
I missed like half of that. 'Cause I was writing down that H equals 3/8 D sub B.
I was still drawing my conical pile.
Alright, dv dt. We are told that it's falling from the conveyor belt at a rate of 10 meters cubed per minute. Now the height is 3/8 of the base diameter, so 3/8 D, which is 3/8 times 2 pi, not 2 pi, times 2r.
Would it be good to denote that as D sub B as in like diameter of base?
It's not really gonna matter.
I know, but still.
If you want to do that, you can do that. I'm
I
not
do.
going to.
And I will.
So this is 3/4 r. So the height is 3/4 of the radius. Or we could say that the radius is 4/3 of the height. Either way. We may need both of those.
I don't know.
And a piece of sand fly away.
How did you find the height thing? Like the 3/8 D?
They told us it.
Okay.
And then diameter is 2 times the radius, which is where the 2r came from.
Okay.
So now they want us to figure out how fast the height is changing first. So that would be dH dt. And then we will also be finding dr dt in part 2.
Fun. Not really good. Fun.
Alright, so for part A, we have the volume is equal to 1/3 pi r squared h. Now, in this first case, it wants us to find dH dt, the change in the height. So I need to replace r with 4/3 h. So V equals 1/3 pi times 4/3 h squared times h. So that's 16/9 times 1/3 is 16/27. So we've got 16/27 times pi times h cubed. Now at this point I can take the derivative. What would the derivative of this be?
dV dt is equal to 16/9 pi r. Wait, pi
And now at this point I can plug everything in. So I've got 10 equals 16 over 9 times pi times Am I missing a piece of information? Oh, well, part B says find the radius, the rate the radius is changing when the pile is 4 meters high, so we're going to use that. So h is equal to 4. I feel like they should have put that before they did the question in parts, but that's okay. So that's 16 times pi over 9. So we've got, when I multiply by that, or well here, let's do this. 10 equals 16 times pi over 9 dh dt. So 90 over 16 times pi equals dh dt.
Rewrite that as 256 pi.
We could if I knew what that number was off the top of my head.
No, the 16 times 16 would be 256.
I know, that's what I said. If I had known that off the top of my head, yes, I would have done that. I don't have my
Oh.
calculator up here.
I just know that one.
Yeah, that's not one of the ones I just know. So, yes, we could have. I was thinking y'all would take the hint and tell me what the number was.
I was just looking at it and it's like, wait, why are we still writing that as that? It's like,
I feel like I
What's
could
this?
have maybe guessed, but I wouldn't have been 100% sure.
Well, yeah.
I would have been like,
So I think 14 and 14 is 196.
yep.
I don't know that. I know 15.
What is it?
225. Don't know
That's
17.
Jinx.
Don't know 17.
That was 289.
I know 20.
All right, what's 90 divided by 256 pi?
Wait, don't say it yet.
Why are you trying to do that in your head?
15 divided by 15 divided by 26.
Josh.
What is it? Tell me.
It's not 15 divided by 26. Alright, so that would be like, I guess, 0.1119.
Now, the problem said, give our answers in centimeters per minute. What do I need to do? So what's the answer?
Hold on, give me a moment. How many per who now?
11.
Centimeters. Yep.
Oh, it just.
Moves? Yes, it does.
I wasn't remembering what the time means.
So this was the answer to part A. Part B then is solving for the radius, change in radius, so dr dt. So here we go again. I already know dv dt. I know that h is, where is it? 3/4 r, and the height equals 4. So h equals 3/4 r. but it's when the height is 4, so 4 equals 3/4 r, so r equals 16/3.
You said we're solving for ERDT now?
Yes. So now instead of replacing r like I did in the last one, I'm replacing h with r. Yeah. Making sure I said the right thing. So now v equals 1/3 pi r squared times 3/4 r. So this is 1/4 pi r cubed. Now I can take the derivative, and what do I get when I do that?
Pi r squared ERDT.
And now we just plug in 10 equals 3/4, nope, pi times 16/3 squared dRdt. Is it 64 pi over 3? I think I did that right, but I'm not sure. Because I'm trying to do it without writing anything down. Doesn't always end well for me.
Yeah, that would be that.
Okay. So then I've got 30 over 64 pi, and obviously I know that can reduce, but we're just going to type it into the calculator. And that's still meters per minute, but I need centimeters, so I get what?
14.92.
So dRdt all the way back up here is 14.92 centimeters per minute. Done.
Yeah.
Problems? 1, 5, 11, 17, and 19.